Alright, so we're going to kind of go through an HMI, and this video is going to be kind of long if I talked through and did while I was doing it. So what I've done here is I've got this HMI. Now just to kind of give you some clarification on what an HMI is, it is a human machine interface, and this little guy is made by Automation Direct. Costs just a few $100s, actually about $300 I think. The Allen Bradley stuff will run you a few thousand depending on what you buy. These things do essentially the same thing, but what it is sometimes we need humans to interact with PLCs. We may need to be able to clear a fault if, for instance, a conveyor were to jam. We may need to be able to just turn a motor on and off virtually without having to buy the hardware and do all that. And we may need to know if that motor is on or off, and there's just hundreds and hundreds of things that we can do with an HMI. But there's programming that goes along with all this. An HMI obviously is made to interface with a PLC. They can do that via the network. They can do that via a hard cable. We're going to be doing a hard cable. So let's think about all the things that have to go into HMI. It's really not that complicated. It's just one of those things we have to kind of wrap our heads around. The very first thing we have to do is we have to set up our HMI to do whatever it is that we're wanting to do. In this case, I'm just making a simple program that when I press the red button, the red light on my traffic light comes on. When I press the green button, the green light on my traffic light comes on. So these buttons and these indicators are virtual indicators. Obviously, they're not real switches in the sense that there's really something opening or closing like there would be with a normally open or normally closed switch or a limit switch or anything like that. It's a virtual button. Same is true for the indicator on here. It's not a real LED light or a real incandescent bulb behind a case. It's a virtual indicator. So those are all computer graphics that are on this screen. And the screen, although right now looks black and white, it's actually a color screen. So the indicator lights are outputs. Now they're not new outputs to the, well, they could be new outputs to the PLC, but in this case they're we're using the output. In other words, on the right hand side you'll see two round circular indicator settings, one for the red, one for the green. Those mirror my outputs of the real world of my green and red light on my traffic signal. The left side's buttons, the little square guys, and they're going to be virtual bits inside the PLC, that B address, just like we have T4 for counters and T4 for timers and C5 for counters, and real world addresses based on slots and bit addresses and that kind of stuff. We have the same thing for virtual bits, so we're going to be using the B3 area of the processor when we assign these things. So the three steps to using an HMI are first setting up our HMI. So I've got this set up already on my HMI. I'm going to go in and let you look at what I've set up. Like I said, it's a pretty long video if I try to do it while you're watching, and let you see that. So the first thing is set up the HMI. The second thing is either to modify or create the program that the HMI is going to be a part of. So this may already be something you have existing and you're tacking on an HMI, or it may be something brand new and you're going to be using an HMI while you're doing something brand new. So this for us is kind of going to be brand new, and it's going to be quick and easy, and you're going to have your own assignment. But I'm going to bring you over to the computer. There'll be some rustling of the screen here, so I can't do that any better just because there's just one of me and a couple of different places we have to be. But right now, if you take a look, I'll swing, before I leave here though, just recall the left side, the square items, there are virtual buttons. The round items with the square around it are just virtual indicators. They're tied to outputs. They'll change color based on whether that output is on or off. So one is an input, or two of those are inputs on the left, the right two are tied to outputs. And right now, I'll zoom out a little bit, and you can see I've got a cable right here. You can see me wiggling it, and it's running to my PC that's over here. And of course, obviously, you can't see the PC tower, but that cable runs to the PC tower. But I'm trying to get you where you can see my screen, and there is the screen I'm talking about. I'm gonna try to zoom in a little bit. There we go. That's pretty close to, pardon the pun, full screen. And we've lost communication with our HMI, and I'm bad about bumping the screen. But you can see right here the colors that I was speaking of that are absent on our HMI, but they're present here. So the left side is that button. The right side is the indicator. So when I click on any one of these, I'm going to click on this one, and I'm going to go to Object Properties. And I'm going to go to Tag Name Database. So this guy that I was talking to is my red button. And notice he's tied to a virtual bit of bit 3. Remember, that's the storage location. And then we're talking about address file area 0, bit 1, and our green button is tied to bit 0. Now these are bits inside the processor. They don't represent any real world I/O. They only represent I/O inside the processor. So if I wanted to turn that red, press that red button on my HMI and turn on the red light, I've got to have a program that says that. So that's the other step beyond this. And then the third thing is I'm going to have my HMI connected to my PLC. Now all that could be done via the internet, but we don't have internet. So the very first thing I had to do was hook up a cable from my HMI to my computer, build this little program right here, and then transfer it into my HMI. And I've already done that. So basically what we're going to have to do now is write a program that says when we press this guy, which is the red button is 0, 1, we want to turn on red lamp 0, 0, and vice versa. So we got a green button. The green button is 0, 0, and we want to turn on the green lamp, which is 0, 2. And I'm supposing those are right. I'm going by memory. I think my red lamp is bit 0. I think my green is bit 2, but we're going to be turning something on or off using these virtual bits. And the output we're turning on is a real world output. It's really the light on a traffic light, but the HMI is going to tell us that too. It's going to light up to indicate it knows that output is on right here. So we get to see a couple of things. Maybe we've got our back to whatever it is that's operating we can't see. So if we had an HMI panel, we know at least we're sending a signal for it to be on. Now just like if my bulb would burn out, my HMI would still come on, but my bulb wouldn't come on. So we could still have some differences, but we know when it should be on. So anyway, that's our bits. Notice these addressing, notice these tie to real world outputs, these tie to virtual inputs. So we've got that done. That's already built. So we had to start that project and get with me when you start this. I'll help you through. You may want to write down a few things about this bit addressing, because it is a little hard even for me when I hadn't been around. But this tag name database is bit 3, and then it'll be 0 for the file storage area, and then whatever bit we want to use. Those could be B3 4:12 if we wanted to, but it's easier to start with file area 0, bit 0, and know. And you'll need to write those down, because when you go to write your program, you're gonna need to know what is what, or you'll be very, very confused when you're doing that. So the green button is 0, and the red button is 1. And like I say, I think the output for red is 0 and green is 2 because yellow is 1 and they're in between. So we've already got that. We've already got it transferred. So now we've got to write a program. And I'm going to pause the video, go out here and connect to our micrologics that's on our traffic light, and I'm going to make you a program. And then we'll go to step 3, which is connecting the HMI device to the PLC after we've got the program set up. So stand by. Okay, so I've created a program, very simple program. Basically says if I press B301, turn on the green lamp. Remember that B301 is one of my virtual buttons. Or if I press B300, turn on my red lamp, which is output 0, bit 0. I'm thinking, pretty sure if I remember right. So step 1, build the interface for the HMI. Step 2, create the program and download it to the processor. And now step 3 is the simplest part. That's connect the HMI to the PLC. So I've got my traffic light here. So I'm going to disconnect my HMI from the computer. It doesn't seem to like to be hooked to both at the same time. I'm going to tilt back and zoom back if I can. We'll have to zoom back further than that. That should be plenty. Now then, I'm gonna, I wish I could get both of these in the shot. That would be gnarly. But the very first thing I'm gonna do, and I'm gonna talk loud so you can hear me, is I'm gonna hook up my HMI to my PLC, because my HMI has got to be in communication somehow, some way with my PLC for the magic to take place. So I've got to take this cable here that is from my HMI. Stay with me where I can do this. In this case, we're going to need about 3 hands. I'm going to hook it to my PLC. So now, as soon as I get this plugged in, my HMI and my PLC will establish communication between them. Now you can't see my HMI, but it looks virtually like it did a moment ago. Now I'm going to come over here and press the red on as soon as we establish communications, which should be very soon. Oh, still waiting. Make sure I'm hooked up in the back. I am. Okay, about to reconnect the HMI to the PLC. A little issue with communications, but we have to figure it out. And hopefully these guys will sync up and we can make some magic happen. There we go. Alright. Let's see if our error goes away and I realize I'm in the camera shot. Alright, and so I pressed the red, and it's saying the green's on, but it's not really. And I'm saying, pressing the green, it's saying the red's on. So I do have those two backwards, but here's the question. Why isn't my green output? Either I've got an addressing issue, or something's going on. So let's pause again, take a look at what the deal is, and we'll be back. Okay, we had a couple of issues there. I've rectified them since then. First thing we had was we had a blown green light bulb. So no matter how much I told it to turn on, ironic that we talked about that, and it happened to us that the indicator was saying something was on, yet nothing was on. And I could hear the relay click on the processor, but no output was coming on. So I figured it was an address problem, or an actual output blown, and in this case it was a blown bulb. And the other thing we have, I had addresses swap. So basically the way I had it set up, when I was pressing the red button, green was coming on. When I was pressing the green button, red was coming on. However, now, and you can't see both, but I'm going to press the red button and you can see the red light comes on. Hopefully you can see that. And I'll flash it a few times. And I'm going to press the green button and the green light will come on. And you can see that. And they can both be on. I mean, not on a real traffic light, hopefully, but with this program, it can be. So right now, you see that they're both on. I'm going to keep us live, and I'm going to come over here to the HMI so you can see the HMI outputs there. And you see we got a red and a green button there. And right now, the red and green indicators are on. So the top one is the red, the bottom is the green. So notice what happens when I press this off. The switch goes gray, indicating it's off, but so does the indicator lamp for the output. So this guy is what's turning the red light on and off, and the guy to the right of him is telling us that. It's telling us that something is happening in the real world. Now I can't touch that, nothing happens when I touch it. Same thing with the green. Nothing happens when I touch it, but if I touch green, the green lamp goes off on my traffic signal, only the red is on. Touch it again, green comes back on, and I get the indicator. So it's a multi-step process. If we're starting new, it's just really as easy as if we're adding in. But the very first thing we got to do is decide what we want to do with the HMI. And I'm going to give you some kind of exercise similar to this to do. So in this case, we just wanted to turn on a red output with a virtual button and a green output with a virtual button, and it made sense that those virtual buttons were red for red and green for green. And we want to know if that happened on the HMI, because one reason for doing this is it may be something an operator can't visibly see, but they need to know it's got power applied to it. So we can actually tie an output to a visual indicator on the HMI. So we had to build and decide what we wanted our HMI to do, decide what we wanted to do, build it. Then we had to integrate it into our program. In this case, it was just build a brand new program from scratch. And it was take a virtual button, turn on a real output, take another virtual button, turn on another real world output. We could see that both with the real world outputs on the traffic light and the real world indicators, the virtual real world indicators on the HMI. So first thing, decide what we want to do with the HMI, configure the HMI, make our program match what we want to do with the HMI, and then last but not least, make sure our HMI and our PLCs are communicating, and that could be through Ethernet or it could be through a hard cable. We're doing it through a hard cable, and it's working like a charm. So there it is. That's the 30,000 foot view. You need to tinker with this and make as many mistakes as I did doing this video for you and have as many issues, and it helps you understand some of the things that are going to happen to you in the real world. Because when you do this the first time or the first time in a couple of years, it's going to kind of be some faded memories. But by the time you're doing this 50 times in a row in the real world, you'll get where you can do it almost with your eyes closed. But those first few times, or those infrequent times, are always a little bit of a struggle for most folks, myself included. But hopefully this clears up what an HMI is, what it's capable of, and this is just a tip of a very large iceberg. We could actually draw something using all the boxes that gives a visual representation of something out there, and let's say it had 5 heaters even on this little display. We could have visual indicators of those heaters and know when 1, 2, 3, 4, 5 or none of those were on, or any combination thereof. So there's a lot of different things we can do with this. We can you know, whatever our imagination and our hardware and software is capable of is pretty much our limits. So anyway, gonna pop this video into your HMI section of your PLCs, and as always, if you have questions to your instructor, again, not every instructor is going to be as savvy on these things. I've spent a good many years tinkering basically with PLCs. So my name's Lee Radney. If you have any questions, again, as always, address those to your instructor on hand at first. But if you need to make an appointment with me to see you about anything, feel free to do that. Don't mind a bit. Helping any student at any time. Just need to know that you need help. All right. Have a great day.